All right, today we're going to start chemical reactions, which is part 2 of our chemistry unit. We've talked about the properties of matter, we've talked about the classification of matter, and the periodic table, and now we're going to look into what happens when elements bond to form compounds. And first, before we move into that, I want to quickly review how matter is classified. So all matter is considered anything that has mass and takes up space. We can divide matter into 2 basic classifications. Is it a pure substance made of one or more elements bonded together, or is it a mixture? It's just a bunch of junked up stuff put together, and it can be mixtures of elements, compounds, elements and compounds, compounds and compounds, mixtures and mixtures. So elements and compounds are both considered pure substances because of their chemical structure. Mixtures can be divided into 2 categories: homogeneous, which means everything looks the same. The particles are dissolved evenly in a mixture. The solute has dissolved into the solvent to form solutions or thicker mixtures like colloids. And heterogeneous, the solute has not completely dissolved. There are still particles that are not mixed evenly. You can see those parts. So iron and oxygen would be examples of elements. Then water and carbon dioxide would be examples of compounds. Milk and tea, they look the same throughout. One's a solution, tea. One is a colloid, milk. The particles are dissolved evenly. And then the example of a heterogeneous mixture would be Rocky Road ice cream. You can see all the parts. Or muddy water, you can still see the parts. So, pure substances is a classification of matter that would include both elements and compounds. They cannot be separated or broken down by distillation, like removing the solids from the solution, filtration, or separating out the colors. Now, an element is made of one kind of atom. It's found on the periodic table. So again, iron, oxygen, lithium, boron would be examples of elements. Compounds, written in set ratio, so think about H2O, NaCl, CO2, NH3, NaHCO3, C6H12O6. There's a specific formula or reason that there are example the C6H12O6. Why are there 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen? When elements chemically combine, they form compounds that have unique properties that are different from the elements that made them. And remember, mixtures are not chemically combined. They can be separated or broken down by filtration, distillation, evaporation, and chromatography. Again, they can be divided into 2 groups, homogeneous and heterogeneous. Now, what do compounds have to do with my life? Compounds make up all living and non-living things. So, for example, where would you be without water? Salt, rubbing alcohol, fats and food that make it taste good, our DNA. So mixtures form by junking 2 or more substances together, just putting them together. There's not a chemical change. There's no energy change. Now, mixtures, they're very important to us as well. We encounter them every day. So again, where would you be without ice cream, Kool-Aid, shampoo, soup, milk, orange juice? All right, now we're getting ready to start our notes for this section. So if you'll look at the outline I gave you, this is called chemical bonds. And a bond is any time something is bound together or connected. So we're going to talk about how things are chemically bound. And so compounds form when the nuclei and the valence electrons, and valence means outer level. So if you remember that group name, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, that tells you the outer level or the valence electrons. So when they combine, It's based on the octet rule, and that prefix OCT means 8. Think about an octagon. It has 8 sides. So 8 valence electrons. And the octet rule is true for all the elements on the periodic table except for hydrogen and helium because they have so few electrons, and they only have to fill their first level to be stable. So elements are going to join with other elements to try to get a total of 8 electrons in their outer level. In CO2, each oxygen has 6 valence electrons, while carbon only has 4. So, if every carbon shares with each of the oxygens, then carbons 2 share with oxygen 6, that makes 8. Carbons 2 share with oxygen's other 6, that makes 8. And that CO2 molecule is a pretty popular bond. So, you're not going to have to write anything on this slide. This is just a kind of for your information, so just follow along. But compounds form to allow elements to become more stable. And by stable, we're talking about 8 electrons in their valence electrons, so they're no longer reactive. Sodium is flammable when it comes in contact with water, and chlorine is a toxic gas. Yet when they combine, salt is a very stable compound. It's neither flammable nor toxic. We put salt on our food all the time, so our bodies need some of it. It's also would actually put out a grease fire, so it is not flammable either. Compounds that are unstable break down and form more stable elements. So compounds can also break down back to their elemental parts, but again, that requires a chemical reaction. Now, this is review. You don't have to write this either. But a chemical reaction, we've already talked about chemical change and defined that. Those terms are synonymous. Is a change in a substance that results in a totally new substance. So when hydrogen gas combines with oxygen gas, we form 2 molecules of water. Again, 2 flammable gases produce something that is not flammable at all, water. Notice that the reactants, what you start with, what is doing the reacting, forms something new, and that is called the product. And think about in multiplication, the answer is often called the product. Again, this is review. In our chemical and physical change notes, we talked about 5 things that we could look for to see if a chemical reaction took place. So, evolution just means production of. So, is a gas produced? Remember the hydrogen bomb balloon when we put the zinc and hydrochloric acid together and gathered the hydrogen gas in the balloon? Is light being produced? We're going to do a couple of labs and demos in the coming weeks, and you will see light being produced. Heat, we measured that in several of them. The beakers got hot or the beakers got cool in some of those chemical changes. Is there a color change? The ammonium and the pennies, it turned to kind of a blue-green color. So there was a change in color. And a precipitant, when you combine 2 liquids and a solid appears in the reaction. And again, we will form a precipitant in one of the labs and demos we're going to do in the coming weeks. We're not going to do the Red Bull in the milk this year because it just does not turn out very well. But a precipitant is an insoluble, that means it doesn't dissolve in something else, that is produced as the result of a chemical reaction. Now, let's go back to our notes. A chemical bond is the force that holds the 2 or more elements together, and it's determined by those outer level or valence electrons. So that electrical attraction between the electrons is what we're talking about here when we're talking about a bond. You might also hear it called the chemical glue. And a stable arrangement is 2 or 8. 2 works for hydrogen and helium, and 8 for all the other 116 elements on the periodic table. Now, tomorrow we will talk about types of bonds and break down into covalent and metallic and ionic and how those occur.